Hey everyone, welcome back to Tensor Titan. So today we are building another machine learning project, a machine learning system that predicts used car prices. Ever wondered how OLX, CarDeco, or other platforms estimates car values? We are building exactly that. Unlike always, we are not stopping at the model. We are building the multiple algorithms and a beautiful web interface with complete deployment. So by the end of this video, you will be having a real world project that you can actually use to check car prices. So let's jump into it. So before we start the coding part, let's see what's going to be the workflow for our project. So first we are going to load our dataset, which is a car dataset which contains 300 plus cars data. And then we are going to visualize our dataset. So we are going to use different types of charts to visualize our data, like creating distribution plot, correlation heat map, or comparing the fuel types to analyze the price trends. The reason behind we do the visualization is that numbers are boring. Charts reveals patterns our eyes can catch instantly. And after the data visualization, we are going to do the data pre-processing, in which we are going to process our data, like some of the values which will be a textual, which we will encoding into the numerical format so that we can use it. So after those data pre-processing, we are going to do the train test split, in which we are going to split our dataset into training and the testing set. So 80% is going to be the training, in which we are going to use to train our model, and 20% is going to be the testing, which we are going to use to test our model. And after the model train test split, we are going to train 3 different algorithms, and we will going to compare them, and after them which will be the best, we are going to use that model as our final prediction model. So the 3 models we are going to use is the linear regression, the Lasso regression, and the random forest regressor. So this is basically a regression problem. So that's why we are using these algorithms. So linear regression is basically finds the best straight line that fits the data. Lasso regression is also like the linear regression, but with a diet plan. It tries to eliminate unnecessary features. It adds penalties for those features which are not good or which are not contributing much to the necessary outcome. And then we have the random forest. And random forest is like creating 100 decision trees and then averaging their predictions. And after that, we are going to do the model comparison, in which we are going to compare all the 3 predictions and find out which one is the better model. So we are going to use 3 matrices. First one is the R2 score, which ranges from 0 to 1. It will tell how much price variation can we explain. Example 0.86. So we explain 86% of price difference. And then the second matrix is going to be the MAE, which is the mean absolute error. So it is like average error in the lakhs. Example MAE is equal to 1.5, which means that typically off by 1.5 lakhs. So it's easy to understand. So you can think of it as like if you predict 100 cars prices and you are off by 1 lakh on average, then MAE is equal to 1. And then we have the RMSE, which is the root mean squared error, which is also similar to the MAE but penalizes big errors more. So usually slightly higher than MAE, preferred when big errors are really bad. And then we are going to do the final task, which is the web application development and the deployment. So we are going to create a web interface for a project, and we will deploy that so that other people can use it online as well. So this was our workflow. So now let's start building our project. So let me just quickly create a virtual environment for a project and install the required dependencies which we are going to use in our project. Okay, so our virtual environment is ready. So now let's start a project. So we will create a file. Let's name it car price prediction.ipynb. So basically I'm going to use a Python notebook so that we can see the visualizations much better. Let's import the necessary libraries. So import pandas as PD, import numpy as np, which is basically for data manipulation. And then for our visualization, we will import matplotlib.pyplot as plt, import seaborn as sns. And from sklearn.model selection, import train test split. It is basically to split our data. And from sklearn.linear model, import linear regression, Lasso. Linear regression is the basic one. Lasso adds the regularization to prevent the overfitting. From sklearn.assemble, import random forest regressor. So random forest, but for regression, it predicts number instead of classes. From sklearn, import matrices. This is for the evaluation of our model. So we will be using R2, MAE, and RMSE from this matrices. And then import joblib, which is basically used to save our model so that we can use it in our web interface. Now we are going to load our dataset. So this dataset have 300 plus used cars data with their details and selling price. Let's see what we have. So we have the car name, which is brand and the model, year, selling price, the present price, kilometers driven, fuel type, seller type, transmission owner. So these are the features we have, which we are going to use in our model. So let's see the shape of our dataset. So there is a 301 cars, 9 columns, not huge, but enough to learn pattern. And let's see the data types. So check data types. Some are integers and some are objects, which is text. So no missing values, clean dataset, lucky yes. So let's see the statistics. So looking at the selling price, minimum is 0.32 lakhs, maximum is the 35 lakhs, and the average is 4.66 lakhs. This range is important. We are predicting anywhere from 0.32 to 35. So this is a categorical data. Most cars are petrols, then diesels, very few PNG. Mostly dealers, some individual sellers. Mostly manual, only 32 automatic in India. Manual is more common. And most are first hand, zero previous owners. Now let's visualize our data sets. By visualizing our data, we will be able to understand our data much better. So if we see, most cars sells between 2.8 lakhs, few expensive ones above 20. This is right split distribution, common in price data. Now let's see the correlation heat map. So look at the selling price correlation. At present price 0.88, strongest, makes sense, higher showroom price, higher resell. Year 0.24, newer cars sell for more. And kilometers driven is equal to 0.03, barely affecting price, surprising. Actually makes sense for Indian market. People care more about car models than exact mileage. And if you see here, diesel car sells for more on average. Why? They are usually bigger, more expensive models. An automatic car sells for more, makes sense, they are premium features. And if you see year versus price, clear trend. Newer cars 200, 2015 plus sell for more, older cars clusters at lower prices. And if you see kilometers versus price, not a strong pattern. Some high mileage cars still sell for good price if there are newer models. Now we will encode our categorical features. ML models needs numbers, not text. So fuel type becomes numbers. Petrol is equal to 0, diesel equal to 1, CNG equal to 2. We are using manual encoding here. Could also use label encoder or one-hot encoding as well. And for seller type, dealer is equal to 0, individual is equal to 1. For transmission, manual is equal to 0, automatic is equal to 1. See, all text is now numbers. The model can work with this. Now we are going to do the feature selections. So we will separate feature and the target. So why we are dropping the car name? It's unique for each car, no pattern to learn. If we kept it, model would memorize instead of learning general patterns. So X is equal to the all features, year, price, kilometers, etc. And Y is what we want to predict, which is the selling price. So X have 7 features and Y has the prices. Now we are going to split our dataset into the training and the testing sets. So we are using the 80-20 split in which 80% is going to be for training, which is 240 cars, and 20% car is going for testing, which is 60 cars. For tree-based models like random forest, scaling doesn't matter and linear regression can work without it when features are similar scales. But if you want, you can add it for better linear regression performance. So here training is 240 samples, testing is 61 samples and 7 feature each. Now we are going to train our different models. So first we are going to have the linear regressions. So linear regression is basically to find the best price straight line. So linear regression is basically to find the best straight line that fits the data, like drawing a trend line in Excel. So it finds the best coefficient. So training means it calculating those coefficients. So now we are going to evaluate our model. So let me explain you these matrices. So R2 score is basically ranges from 0 to 2. It tells us how well the model explains the variance. Like what percent of price variance can we explain? So 0.87 means that we explain 87% of price differences. And then we have the MAE, which is basically tells the difference between the predicted and the actual, like in lakhs. So 1.2 means that we are off by 1.2 lakhs on average. So easy to understand, we are typically wrong by this much. And then RMSE is which means that similar to MAE but penalizes big error more. Also in lakhs, usually slightly higher than MAE. Now for the training set, the R2 score of 0.88 is great, model learned well. And for the test, if we see that 0.84 still good, close to the training means no overfitting. And if we see the MAE of 1.2 lakhs means our predictions are typically off by 1.2 lakhs. For a card selling at 5 lakhs, that's about 30% error. Not bad for a simple model. Now let's see the visualizations. So this scatter plot shows predictions versus actual. Red dashes lines is equal to perfect predictions and pointed close to the lines is good predictions and point far from the line is equal to the error. So most point clusters around the lines, which is a good sign. Now we are going to train our second model, which is the Lasso regressions. So Lasso basically adds the regularization, a penalty for having too many features or complex coefficients. So the benefit of this is that it prevents the overfitting, can eliminate useless features and makes the model simpler. By alpha is equal to 0.1, which controls how strictly the penalty is. Higher alpha is equal to more penalty is equal to simpler model. So as you can see that the results are similar to the linear regressions. Usually Lasso helps more with high dimensional data with only 7 features. Both works well. Now the time is for our third model, which is the random forest. So random forest for regression, predicting numbers, not classes. So how it works is basically it creates 100 decision trees and each tree makes a predictions and the final prediction is going to be the average of all those trees. So why this is powerful is because it captures the non-linear patterns unlike linear regression and handles the outliers well. So generally more accurate but more complex and slower. So training 100 trees might take a bit longer. So if we check the R2 score for the training, 0.96. So this is very high. And if you wait for the testing, that R2 score still good but lower than training. This is slightly overfitting. Random forest memorizes the training data a bit, still perform well on test data though. Now the feature importance. So random forest tell us which feature matters the most. Like present price 0.80, which is important, by far the most important. Year 0.10, second most important, and kilometer driven very low, barely matters. This confirms our correlation analysis. Now we are going to visualize our features importance. So visual makes it even clearer that present price dominates. Now we are going to do the model comparison. So let's compare all these three. So R2 score linear 84, Lasso 85, and the random forest of 0.94. So which is clearly the winner. So now we are going to save our model. So now we can use it in our so that we can use it in our web app without retraining it again and again. Okay, so now let's try start model. So this is a 2015 petrol manual 50 kilometers and the 7 lakhs showroom price. So if we see the predicted price, which is 4.18 lakhs. So this is the predicted price of this car. Okay, so now our model is ready. So now let's start the web interface. So now we are going to create a file. Let's name it car-app.py. We are going to use the Streamlit to make our web interface for our ML project. So we are going to import some libraries like import Streamlit as ST, which is going to help us in building the interface. Then import pandas as PD, import numpy as NP, import joblib to load our model, and import plotly to graph object as Go for our graphical representations. So plotly basically creates beautiful interactive visualization, which is better for the web apps. Now we are going to configure our page. So title that appears in the browser tabs, and layout is equal to wide, uses full size screen width. Now we are going to put some custom styling like red color for headers and making it look which makes it look professional. Load the saved model with caching. If the file doesn't exist, return none. So this st.cache resource basically loads model once and reuse it. Otherwise it would reload every time user changes input. Now we will check that if model exists, if not, show error and stop. User needs to train the model first. Now we are going to create the sidebar for input. So all user inputs go here, keeps the main page clean. Year slider from 2000 to 2024. So default is 2015. Why 2000? Cars older than that are rare and data pattern changes. Now present price st.sidebar. Numbers input for showroom users can type exact values like minimum 0, maximum 50 lakhs. Covers most cars and default is 5 lakh. Step is 0.1, allow precision. Now kilometers driven up to 5 lakhs, default to the 50,000 and step is 1000. And drop down for fuel type like select box creates drop down to different from sliders, categorical choices, not continuous numbers. More drop downs for all categorical features. Notice how we are matching exactly what our model was trained on. Now calculate the car age, useful for displaying and tip later. A big beautiful predict button. The type is equal to primary, makes it blue and prominent. Use container width, stretches across full sidebar. Now everything inside this, like if only runs when button is clicked. Encode categorical variables same way we did differently we did during training, and critical. Encoding must match training exactly or our model won't work properly. So we will create data frame with exact same columns or order as training data. Even though it's one row, we use list to create proper data frame. Get predictions, return array we take index 0 to get the actual number. Now calculate the depreciation, how much value the car lost, precision. This is super useful info for users. Now we are going to display results. So create 3 columns for side-by-side metrics, makes info scannable, and Streamlit metrics widgets like large prominent display, perfect for key numbers, can show delta, but we are not using it here. Show original showroom price for comparison, like depreciation with percentage. Delta shows the percentage with down arrow, visual indicator of loss. 2 columns, but 2,1 makes left columns twice as wide. This needs more space than the gauge chart. ML predictions aren't perfect. Real prices vary based on car condition, location, season, negotiation. Range gives realistic expectations. Now, dynamic feedback based on car age. Green for good, yellow for neutral, and red for concerning. This helps users understand that why behind the car. Mileage feedback under 30k is excellent, over 80k is high. Additional factors like notice we only add message for relevant cases. We don't say manual transmission is bad, just highlight automatic is premium. Display all factors are bullet points. A Plotly gauge chart, super professional looking, shows predicted price as a gauge, like a speedometer but for price. Interactive, hover to see exact value. So configuration is going to be the very low price, heavy depreciation, yellow means medium price, green means high price. The red bar shows where the prediction falls. Blue threshold line shows the original showroom price, easy to see. My car was worth 8 lakh, now it's worth 5 lakh visually. Adjust size and display. Use container width makes it responsive. Here's the summary of all input. User can verify did I entered everything correctly. Notice in kilometer driven adds commas, which is much more readable. This runs when the button hasn't been clicked yet. Show helpful instructions so user know what to do. So examples cards give user an idea of what to expect. These are realistic examples based on our model's typical predictions. Different car types helps set expectations. Show model info builds trust. User knows what algorithm we are using, how accurate it is, how much data we trained on. Transparency is important for ML apps. Okay, so now let's run it. So we are going to type streamlit run carapp.py. So now let's check that how good our model is working. So as you can see that our model is working fine. It is predicting the car prices very well. So this is actually useful. You can check if you are getting a fair deal. Okay, so our model is working fine. So yes, we can see that it is working. Now let's deploy our model. So now for deploying our model, first we have to put our code on the GitHub, which we are going to use to deploy our model. And we are going to deploy our model through Streamlit Cloud. So let me just quickly put our code on the GitHub. So now our code is on GitHub. Now let's go to the Streamlit. Let's create a new app. Here we are going to put our repository. And after the repository, we are going to select our app. Type the name of the website. And click on deploy. It's going to take few minutes before deploying. So now our website is live. So you can see now we can predict our car prices very easily, and you can put this link in your resume so that anyone can use it and see how the model is working. So that's it. We created another machine learning project. So if you like the video, do like, comment, and share. And all the code is in the description. So start the GitHub repo and drop a comment with your deployed link. I love to see your version. And if you learned something, smash that like button, subscribe for more ML projects, and turn on notifications. And if you have any question, drop them in the comments. I will reply to everyone. So thanks for watching, and I will see you in the next video. This is Tensor Titans signing off.